So 2023, we're now starting paper two's questions. So there's quite a lot in paper two that we can do from all the stuff we've done in fifth year. So probability here is the first one. So let's have a look. So we have a circular spinner. It has 12 sectors as follows. 5 sectors are labeled €6, 3 are labeled €9, and the rest are labeled 0. So I suppose might be no harm to write in what the rest are. So 5 and 3 is 8, 9, 10, 11, 12. So 4, the 4 remaining ones means you get nothing, basically. In a game, the spinner is spun once. The spinner is equally likely to land on each sector. The player gets the amount of money shown on the sector that the spinner lands on. Fiona plays the game a number of times. Work out the probability that Fiona gets €6, then €9, then €6 for the first 3 times she plays. Give your answer correct to 4 decimal places. Okay, well, this is really the fundamental principle of counting. So what's her chances of getting the 6? So getting the €6, so just doing the €6, well, that's a 5 in 12 chance. Then a €9. Well, to get a €9, you have a 3 in 12 chance. And then to get a €6, again, you have a 5 in 12 chance. So work out the probability she gets 6, then 9, then 6. So it's not one or the other, it's an and question. So it's a multiply. As I said, the fundamental principle of counting, really, you're multiplying the 3 of them together. So we then correct our answer to 4 decimal places. So 3/12. 5/12. We then multiply by 3/12. And then we multiply by 5/12. Okay, so as a decimal, it's 0.04. Is 0.0434, and that is to 4 decimal places. Okay, the next question. Rowan also plays the game a number of times. Find the probability that Rowan gets €9 for the 3rd time on the 8th time that he plays the game. Okay, we better read that again. So the probability that Rowan gets €9 for the 3rd time. So in other words, he's gotten it twice already. So what is the probability he gets €9 for the 3rd time on the 8th time that he plays? Okay. Now, that means if it's on the 8th time, hopefully you'd agree he's already played 7 times. And out of the 7 times that he's played, twice he's gotten success. Success in this case being the ability to get €9. So I'm going to put my success here. Now, what is my success again? Well, to get 9, what are my chances? There's a 3 in 12 chance. So you can say 3 in 12 chance. Well, that's a quarter. So I might just write that as 0.25 or a quarter. It doesn't matter. Failure would be 0.75. And then, of course, the 2 goes there. So whatever's at the bottom goes there. And then you do 7 take 2, which is 5 for here. Now, on the 8th time, so he has one more go. And on that one more go, he has success once because, from 1, he gets 1. In other words, from his one go that's left, he gets another 1 success. Failure, well, failure doesn't happen in this case because out of that 1 remaining go, he does have success. Now, this is also an and question which means it's multiply, because he's gotten 2 successes initially, and then he's getting this other one on his last go, which is his 8th go. So now all I'm doing is reaching for my calculator, and I'm letting the calculator do the rest for us. Now, if you've forgotten how to do any of this, go back on the notes. We would have done all of this under probability and the binomial. So we combined, I suppose, what we knew about the binomial theorem with probability. So I'm just writing some of the figures here so you can just compare them to your calculator when you go doing it yourself or go checking your questions. Now, this one's kind of a long one, so I'm just going to write down a few, but of course, leave your calculator as it is on screen. Now, 1 choose 1 is 1, 0.5. So all of this is going to be just 0.25. Anything to the power of 0 is 1. So it's 0.25. So multiplying it all now on my screen here, 0.25. So I get 0.077865, etc. 4 decimal places, so 0.0779 is the correct answer. Ogla plays the game 2 times. Find the probability that Ogla gets less than 16 in total from playing the game. Give your answer correct to 4 decimal places. Okay, so she plays twice, and we want to know the probability that she'll get less than 16. Okay, well, let's think about it. So go back up to our options. I mean, if it's less than 16, she could win nothing at all. That's one option, that she never wins. Another option is, I suppose, that she'd get 0 the first time and then €6. Or she might get 0 and then €9. And actually, even if she gets a 6 and then a 9, she's still under €16. And if she gets a 6 and a 6, she's under €16. So there's actually only one scenario where she would win over 16, and that would be if she won 9 and 9. So what I'm going to do is I'm going to do 1 minus the probability that she does win 9 and 9. That's much quicker. So 1 minus the probability that she gets 9 and then 9. Okay, so what is the probability of getting a 9 in this question? So sorry, I'm going to have to check back. 9 is 3 out of 12. So 3 out of 12. Yeah, so it's a quarter. So the probability of getting a 9 is a quarter. And a 9 is a quarter. So it's going to be 1 minus, so I'll just multiply maybe those. So a quarter by a quarter is 1/16. So 1 minus 1/16. So she's a high probability, 0.9375. So she's a high probability that she can win less than 16 because there's only one time she can't, and that's if she wins 9 and 9.